So, welcome to Lambda Alpha Physics. The following videos are meant to be a non-exam based introduction to physics as a whole, which means that if you're watching this in preparation for studying an exam, I wouldn't recommend it. I'm not tailoring this to a specific exam board for any country or any exam board within that country. This is mostly just some general information that you should know if you want to study physics at any point, if you maybe don't have the resources or just want to see what physics is like before you actually take it, maybe as an exam subject. So in the units of the basic introductions presentation, which is going to be this, split over a couple of videos, after this series rather, you should know how to solve a mathematical problem, the 7 base SI units and the SI prefixes, this concept rather known as significant figures, and how to use dimensional analysis, which is a neat little trick to check for the accuracy of a formula. So a lot of that might seem, a bit confusing, but after this entire series, then you should be fairly comfortable with all of these 100%. So the big question is what physics actually is. So it's the natural science that studies the fundamental principles that govern the actions of matter and energy in the universe. It encompasses a wide range of phenomena, from subatomic particles to the universe's largest structures, such as stars and planets. It's also the study of fundamental laws that govern these natural phenomena, like motion, energy, force, and the behavior of matter and radiation at both the atomic and subatomic levels. Physics knowledge overall has resulted in advancements in technology and science, like computers, telecommunications, and medical advances. This image here, by the way, if anyone's curious, we will get to this. This is called the Newton's Cradle, and it demonstrates this thing called PCLM, Principle of Conservation of Linear Momentum, but obviously we'll get to that in due course. So one common misconception with physics is that you need to be, top of the class in maths. You need to know all these complex things like matrix multiplication or, I don't even know, partial differentiation. But really, at a fundamental level, and for most of the introductory stuff, you only need to know 3 things. Algebra, such as solving quadratics, like the one on screen. Trigonometry, so Pythagoras' theorem, and typical trig ratios, such as tan, theta, opposite over adjacent, and some basic calculus. When we get to simple harmonic motion, we are going to have to go into second order differential equations, but I will pretty much gloss over the maths part of it and just show you what has to be present in the physics solution. So there's nothing to be scared of. I know second order differential equation sounds incredibly daunting, but I promise it's not going to be too bad once we get to it. So, the problem-solving strategy with physics is very important for the mathematics. So, it's helpful to remember 3 stages of problem-solving. Now, these problem-solving stages aren't universal. It's not meant to be a one-size-fits-all sort of thing. It's just meant to be so that you can solve a physics problem in a certain amount of stages in a consistent manner. So often people get bogged down in a question with random formulas all over the books or exam papers, but if you follow these 3 stages, then you should be fairly competent in solving any basic physics question. So what are the stages? Well, the first stage is to dissect the problem, to underline key terms and figures and note the units. For example, 25 meters per second is a key figure. So you'd probably write down, because 25 meters per second we'll just assume is a speed, you'd probably write V is 25. That's something you'd probably write. If there was another value like distance, you'd write D equals 100, and then you could work out from there any basic knowledge that the time taken is 4 seconds. So, you're to underline and note the 25 meters per second, but not say your car has broken down, because it doesn't change the answer you get. So it could be your bus has broken down, or your bike has burst a tire or whatever. So long as the figures aren't dependent on like the English part of the question, then it doesn't really matter, but you should still underline the key terms. Second thing to do is to spot equations. So when you write down your variables you've just spotted, you may be able to recall the specific formulae. So some of the formulae we get are really complicated. For instance, the Doppler effect looks like this. The fundamental frequency of a string looks like this. So even if I just isolate the Doppler effect, if you're given f dash, f and c, you can get u. You just got to remember sort of the order that it goes in. So even if you write down everything, so if it's a Doppler effect question, for instance, which is the apparent change in frequency as an object moves, if you spot that the wave speed, which is c here, if you spot that that's 340, and you have your actual frequency and your speed of the observer, then you could form those values together, and you're more likely to remember that way instead of memorizing a big chunk of formulas. And lastly, solve. Essentially, you're doing the maths at this stage. That is a quote from the Young and Friedman University physics that I like very much. Simply substitute and solve. Sometimes, not often, but at times you'll reach simultaneous equations, but sort of at this point I should expect you to know how to solve simultaneous equations like that. So if you're not, then I recommend you look at how to do that. Even if you go back here, if you don't know any of the mathematics that are on screen, I recommend you take a look at those before you move on to the next video.